As our programs grow larger, they're easier to maintain if we put our C code in multiple .c files. This video will talk about how we decide what goes where. Before we can put our code in multiple files, we need to understand one important thing about the C compiler. It reads the .c files from top to bottom. When it sees a function call, it needs to know what parameters the function is expecting and what return type that function will have. That means that the declaration of the function needs to be above the calls in the file. However, sometimes the way functions call each other means that we can't always put the entire function above the call on it. We can give the compiler the information it needs by putting just the information it needs near the top of the file. These clues are called function prototypes, and it's just the declaration followed by a semicolon, no code block at all. In this example, I have two functions, and you can see their prototypes here near the top of the file. Now, in this example, you could say that I didn't need to do that. Primes between calls isPrime, and it's declared before it's called, so the compiler would be okay without the prototypes. That's true. However, it's considered good form to always include the prototypes. That way, we can order the functions in a way that makes them easy to find. Lots of teams like them to be either grouped by related functionality or in alphabetical order. As our systems grow, if everything went into one .c file, things would start to become very difficult to find. In addition, having everyone on our team editing one file can make things more complicated. Therefore, we want to spread our source code across multiple C files. We try to find groups of related functions and put each group in its own source file. For example, if we were building an embedded system using a PIC controller, we might want all of the functions dealing with LEDs in one file and I/O ports in another file. And then our main contain higher level functionality of our app, like making LED patterns or handling various inputs. We've already kind of seen this. We include standard.io.h. That's a clue that all of the functions related to standard I/O operations are in their own .c file. When our code is spread across multiple C files, the build process will first compile each individual .c file, usually into a .o file. Then software called a linker will put those .o files together to build our app. So, when it's doing those individual compiles, it needs to know about the functions in the other files. Now, we could put the prototypes in every .c file that needs them, but that would be really hard to maintain. When we change a function's declaration, we'd have to change it in lots of places. There is a better solution. Remember that standard.io.h file? It contains the function prototypes for all of the functions in standard.io.c. So every .c file, except maybe the one holding your main function, needs a corresponding .h file. These are called header files, and they contain the function prototypes for the functions in the matching .c file. Remember, the #include directive tells the preprocessor to take the text from the included file and expand it into our source file. So when we #include standard.io.h, all of the prototypes in that header file get put into our source file near the top. Now the compiler has all the information it needs to compile our code. In this example, I've put the functions relating to calculating primes in a primes.c file, and I've created a .h file with the prototypes of the functions other files might want to call. Then I created a runner with a main that uses the functions to build my app. Here, I included standard.io.h and primes.h. Notice the libraries that come with C have triangle braces around them, where our H files have quotes around them. After the preprocessor runs, standard.io.h will be expanded. I didn't put all of that here because it's huge. And primes.h will be expanded. That puts our function prototypes near the top of the file, just where we need them. With this structure, when one of the functions in primes.c changes, we change it in the header file too. That lets everyone else get the change at once. That begs the question, what goes in the header file? Well, the answer is anything that someone using that .c file's functions might need. Clearly, that means we need the function prototypes. We also need any type defs or structs that are used in those function calls, any pound defines other people might need, and so on. There's one more detail to building header files. Often, one header file will include another one because the function prototypes use something from a different header file. That's fine. But now that means we have to be careful. It's really important that we don't include the stuff in a header file more than once. If it includes pound defines or external declarations, that can confuse the compiler and linker terribly. We prevent those problems by making sure that even if we include the header file multiple times, the actual code will only be expanded once. To do that, we use another compiler directive, ifndef. That's saying if not defined. It's given a token that could be the name of a pound define. If that token has not been defined, then the code between the ifndef and the endif will be included. If that token has been defined, all of the code will be skipped. Then we put the definition of the token inside the pound ifndef. The first time we call this file, call stack1 primes h will not be defined. So the define and all the function prototypes will be included in our source code. If we included it into that same C file again, call stack1's primes h would already be defined, so the define and the prototypes would not be included again. These structures are called header guards, and you should always include them. The token is always based on the name of the header file, so it's unlikely anyone would have already defined that token. I think that's all you need to start spreading your C code across multiple .c files. We'll have to talk again when we want to share data between C files.